Hello everyone. In this video, I'm going to talk about Keras initializers. In a deep learning model, we have two things. We have a kernel initializer and a bias initializer. We have different options for these. So when we train a deep neural network, so for example, this is an input layer and this is our output layer, and these two are hidden layers. When we say we train a deep neural network for our data, what we mean to say is basically we are trying to find the weight matrices that define the hidden layer connections between this, and this. Now obviously there are multiple options that are given to us within Keras. So one of them options is 0, so all the weight matrices will be initialized to 0 or 1s or any constant value. It can come from a random normal. So this basically gives us value with mean 0 and standard deviation of 0.05. We can choose random uniform where the minimum value is minus 0.05 and the maximum value is 0.05, and it basically generates a tensor with from a uniform distribution. Truncated normal is what is preferred by many people, and this has a mean of 0 and then standard deviation of 0.05. Variance scaling is another option. Orthogonal, it creates an orthogonal matrix, so the inverse is the same matrix. The identity matrix where all the diagonal is 1. Lacan uniform, Glorot uniform. Now I would suggest you go and read this paper. This is a really good paper to get an understanding on difficulty of training deep neural networks. It was written by Xavier Glorot and Yosha Benjo, and based on his name, it is called Xavier initializer. And in this paper, what they see is they're trying to find what are different things because of which it's difficult to train a neural network, and then they came up with an idea on how to initialize the weights properly, so that we do not have any vanishing or exploding gradients in this neural network. What happens is if we initialize these weights randomly, it might be possible that after some certain point of time, the changes in the weight during the back propagation will be almost negligible, so these will stabilize, and then we would be stuck in a local minima. Or if the weights are changing really high, then what we'll be doing is we'll be just moving in the stochastic gradient descent in a valley, and will never reach the minima. So there are different options available, and HE normal, this is one of the recent from the paper that's given here. So in this video, what I'm trying to do is I'll try to and then this is the video that I was talking about. This was basically written from Microsoft. So in this video, I will first import Keras backend as K. We'll just use a sequential simple model and use a one dense layer. We'll use NumPy when we are making our own initializer, and then constant. These are the possible options that Keras provides out of the box. Please note that if you just give constant, it gives a default value of 0, but I wanted to change because we already have zeros here, so I want to change it to 2. So that's why I add this. Then other than that, everything is the same. If we need to use the default values for all these, we can use just the string. If we need to change any value, for example, let's say for truncated normal, we want to change the mean and standard deviation to a different value. It's better, what we need to do is we need to import from Keras initializers and import truncated normal, and then while initializing it here in the kernel initializer, we just put the values that we want. For the time being, I'm using default values, and the idea is what I'm doing is, so if we want to keep the weights constant, we should put the seed constant. So when you run the code, you'll get the exact same weight that I get here. If you don't have this, then it will basically be random with every run. So for the initializers that we have, I'm just defining a simple dense model with two output layers, two output and then input dimension of 5, and then initializer from one of these. Then we then compile the model with RM's prop as optimizer. You can have anyone as, let's say, Adam or SGD, it doesn't matter right now, and the loss is MSE, and the metric that I've used is accuracy. Then the next is basically from for each of these layers that there are in the model, we get the weights from using this method, and then we print the weights. So when I run this, what it does is, as expected, we have input dimension of 5 and output dimension of 2. So the layer that we have has a shape of 5,2, and then for zeros we have all zeros, for ones we have all ones, for constant we have 2 because we have specified value 2. For random normal, it comes from a normal distribution between 0.05 and minus 0.05, and so on and so forth. So one question that you might be asking is which one to use. So what I do is I basically use a truncated normal when I have a shallow network. When I say shallow network, up to 1-2 layers. When there's a deep neural network, if I'm working on, then I use the Gloreth or the HE, one of the HE initializers. What these do is, from experiments, they found was when we initialize these weights using the Gloreth and the HE normalizers, initializers, it doesn't get stuck in the local minima, and then the problem for vanishing or exploding gradients is reduced. And here is how we define our own custom initializer. Let's say this is the name of the function, and what we do is we return this, and we make this simple layer, and then once we run, we get the output. So this is how we can use the initializers in Keras, and we can define our own when possible. I hope that you like this video. If you liked it, please subscribe my channel to watch for more videos. Thank you.